pop up a little next section thing. Now we want to get back to our IMDB stuff. And let's do some more examples on IMDB to kind of talk about other things we can do with dictionaries. Right? So we had the IMDB data, and if we look at Hanks on the IMDB data, let's pull that up for a second. And I can get rid of a bunch of these now. There's Hanks. One of the things we're going to notice is that old Tom, he had a lot of roles in Polar Express. I think, among other things, he was the executive producer and the director and a whole bunch of other things. So he appeared in Polar Express a lot of times. So we're counting how many movies he appeared in. We're actually accounting the same movie over and over and over again. So it might be nice to find out how many movies did he really appear in, you know, instead of just giving himself extra credits for that one Polar Express movie. So if we want to do this, we want to maintain a uniqueness. We don't want to just count every time we see Tom Hanks in a movie. What we want to do is we want to count every time we see a unique movie. And a good way to do that would be probably to use sets. So let's start off from our set example. You know, we got all the way to here, right? This is the stuff that we give you every time. I'm going to keep this counter in there. This is the only line that we actually had to put in there to get our set operations to work. The rest of that was the counters to keep track of how many things we've seen. We gave you this. We could also do something like Control-C, VV, name, title, and year. Right? That would be 0, 1, and 2. So these are all the values that we can extract from that file. And now what we want to do is we want to say, okay, when we see an author, when we see an artist, Tom Hanks, for example, if they're already there, well, we want to maintain a unique grouping of movies. So we're going to make this a dictionary. And I'm going to call this movies instead of name set. Right, so movies is going to be our dictionary. The keys for the movies are going to be actors or people who appeared in the movie or were associated with the movie. And for the values, what we're going to do is we're going to maintain a set of all the movies that person appeared in. And this is going to allow us to do with this uniqueness thing, right? We want to know how many different movies did Tom Hanks appear in. Okay, so let's come into here. We'll do that. Actually, here we go. This one's better to start from. Actually, even better to start one would be the IMDB set or IMDB counting dictionary. There we go. Let's start from here. All right, so we have our dictionary. That's our counts. I'm going to call this movies. It's going to be a dictionary. We're going to walk through. This is our printing out stuff. We're going to do our name, title, year. I'm not sure if this saved me any time or not. Length of movies. Okay, so all we're going to do is we're going to walk through here. We're going to create a set for every actor. And as we find a movie, we're going to add it to that set. So at the end, what we should have down here is a dictionary with a bunch of movies in it. And we'll be able to go through and see how many movies everybody appeared in, you know, uniquely. So all of this is just up to line 17. It's just getting the information. We've done this over and over again, so it's not worth going into too much. But let's look at what we have to do. Well, we have to ask if name in movies, right? Name is going to be the actor's name. And actually we want to ask if not name in movies. If the person hasn't already been put into our movies dictionary, well, then we have to put an entry for them. So we will say, we'll add an entry to them for them. Movies subname, right? That's how we create an entry. Now we have to assign it something, and all we're going to do is assign it an empty set. If we don't hit this line, then we don't create an empty set. So we're only going to create an empty set when the person isn't already there. After this point, we know they're in this. We know they're in our dictionary because we either just put them there or they already existed. So now we can just do movie subname. Right. This is going to be a set because that's what we've just set up. Right. Every actor is going to have a set of movies associated with them. So we can just do movies subname dot add title. Right? And that's going to add in the title for this movie. If the title already existed, well, this is a set, so it's not going to add it. If the movie didn't exist, it will add it. And if we run this on hanks.txt, I think Tom had 42 movies previously. We run this now, Tom is down to 35 because 7 of those movies were duplicates. I think he appeared 8 times in Hanks in Polar Express. So that's kind of giving us what we want. And if we want to actually see what the movies are, we can pull that length out and we can run this again. And now what we'll see is instead of getting how many entries are in that set, right, we get the actual names of them, names of the movies that they've appeared in. But that's, as you get up to 50-some or 40-some movies, that starts getting to be kind of long. So I think we're just going to leave the length in for now. And because we've done this all with dictionaries, we can do this even on our big IMDB data.text, and it should work pretty good. Okay, so it just kind of rips through there. The limit here is really, and we're just printing out, by the way, no more than 100 entries. So that's the first 100 in alphabetical order, right? We're sorting by the artist's name. So let's flip this. We now have a dictionary, movies, and movies has a set associated with it that are all the movies that each individual appeared in. And now, having read that, let's try to figure out who's busiest. And let's do this. Let's say we want to ask this question a lot, so we want to walk through our dictionary once, do it right, and create another dictionary that maybe we can sort and find out by the number of appearances. So that if somebody appeared 36 times, the index for them would be 36, and then the value would be the list of people who appeared 36 times in movies. And what that'll allow us to do is it'll allow us to actually sort. We don't have to walk through our dictionary looking for, It's just another thing to do. Let's be clear. Okay. So let's look at how we would do that. Well, we already have our dictionary, right? Our dictionary movies. Now we want to know occurrence. Well, I'll say occur. So occur is going to be another dictionary. And the keys for occur are going to be how many times a person appeared in a movie. And the values are going to be a list of the people that appeared that many times. So if we want to know how many people appeared in one movie, right, we could look at occur sub 1, and we would find a list of all the people that only appeared in one movie. And we're going to use a list, because we can do that because all of our people are going to be keys from our previous dictionary. And we know that the keys from the previous dictionary are going to be unique, so we know that each individual is only going to show up once. So we don't have to worry about duplicates. We can just use a straight list. We could use a set as well. That would be perfectly fine, but we don't have to. So how do we walk through our dictionary? Well, for keyinmovies.keys, we'll walk through the keys and give us one at a time. And then we know that having walked through those keys, the value at movies subkey is going to be the list of movies that actor key appeared in. So key is going to get set to all the actors one at a time, and movie subkey is going to be their set of movies they appeared in. They're going to come out in random order, but we don't really care about order because we're going to put them into a dictionary and they're going to be randomized anyway. Okay? So now we can say, I don't know. I'm going to call it capital S, or let's say movies. I guess movies is movie set. Movie set. That's good. We'll call this movie set because we don't want to overwrite any of our variables. We'll call this movie set equals movies, right? Our movies list. And it's going to be indexed by the actor, and the actor is the key. And the value we want is how many movies did this person appear in. So the value is going to be the length of the movie set. Right? So if Tom Hanks has 35 movies in his movie set, he's going to be stored at index 35. He will have appeared in 35 movies. So we can do value equals length movie set. And now our occur dictionary is going to have as keys these sequence of values, and it's going to have as values lists of the actors who appeared that many times. Well, our actors in key, value is our length parameter. So all we have to do is we have to ask the question, if value, if not value in occur, right? If the value isn't in the occur dictionary already, then we want to say occur subvalue, right? So we're going to create a new entry for that number of occurrences, and we'll just set it to an empty list. We could set it to a set, but as I said, these are all going to be unique, so we don't really need a set. And then we can just say occur.append key. Right, so now we're going to add the actor onto the list of, as having appeared in that many movies. Okay, there's an alternate way to do this. I'll just show that as well. We could actually just seed the key, and we could do an else, and then do that. This is equivalent. I like the other construct just because it's fewer lines to type. That's important to me. All right, so if we run this, hopefully this will work. Syntax error, invalid syntax. It doesn't quite work because we need a colon there. Run it again. Let's look at hanks.txt. dictionary occur sub value dot append. All right, one more time. All right, this is still from down below here, and Tom's at 35. But if we look at the occur array now, right, we can look at occur, or occur dictionary, right? There's a lot of stuff in there. We can ask occur 35. That should give us the list whose member's Tom. If we look at occur 1, that should give us a whole bunch of people. Bethan, Bridget, Scott, Mark, Brad, Steve, Christopher, Mike, and Paul. I guess there's a 2 in there. We could look at 2. We can look at the length of occur, and that should tell us there are how many different values there are, right? So it says there's 1 6, 1 10, there's a 6, a 10, a 1, a 35, and a 2. So that'll tell us how many keys there are in the occur array. So that works out pretty good. And we can do the same thing if we want for imdb.text. Right, and this will run through pretty fast. And we can ask for IMDB. We can now look at the occur array for 35 again. And now hopefully we'll have more than just Tom. But we do have, well, actually, yeah, there's Tom. There's Tom Hanks. He occurred 35 times. Sandra Bullock occurred 35 times. Jane Fonda, Dean Stockwell. Right, so these are all the people in our database list who starred in 35 movies, or who appeared in 35 unique movies, because we made sure up here that our movies are unique. And this kind of conversion is something we want to be able to do. You should be able to do this relatively easily over and over again. Maybe we want to print out the first 100 instead of doing our movies keys. Maybe we want to print out the first 100 of our occurs list. But maybe we want in reverse order. Maybe we want to go, the busiest first instead of the least busiest first. We can do this. Let's do this first. These should be all the people who starred in the fewest number of movies. Let's see, this gives us, I should probably test this with Hanks.text first, but we will just jump in and bite the bullet. Of course. All right. So there are 86,000 people, 86,735 people starred in one movie, 15,789 starred in 2, and we could just keep going up or down. We get down to 338 people. One person starred in 338 movies. If we want to know the opposite direction, there's a little flag on sorted that we can put in. This is something you're going to want to know. If we want to sort from high to low instead of from low to high, we just put in this little flag, reverse equals true, and this should give us the same data, but in the reverse order. And there we go. And if we look at occurs sub 338, right? Or occurs sub 338, hopefully that will be my man Mel. Anybody know who Mel Blanc is? Mel Blanc did actually have some starring roles as Mel Blanc. But mainly he did sound effects. He's the voice of some of your favorite cartoon characters. All the
Flintstones and the Jetsons, right?
I don't think, I'm not sure he was on the Flintstones. He was on like Bugs Bunny, Porky Pig, the Looney Tunes guy. He was really into the Looney Tunes, or he was really a Looney Tunes guy. I'm not sure Jetsons were Looney Tunes. I think they were Hanna-Barbera, and Fred Flintstone as well. But yeah, it's
He voiced Barney on the Flintstones.
did he?
Yes.
I'm absolutely willing to believe that. He also did train whistles and all sorts of other vocal sound effects. So he deserves to be number one. All right. Where are we?
He was Mr. Spacely on the Jetsons too.
Mr. Spacely too. So that was the thing, is they on all of these shows they tended to use the same actor for multiple roles. I'm not going to go over all of these. There's a lot of different things we can do now, but you should kind of think about how we would want to do these. Right? We have an actor's dictionary with actor names and whose values are sets of movies. We constructed a dictionary whose keys are the number of occurrences of the person in the movie database. So, essentially the number of unique movies they starred in. We could also go in the other direction. We could have keys are movies and values are sets of actors. And using all of this, we can actually build up chains. So think about how you might want to, how we might go through solving this. For example, if we want to find out, solve the degrees of Kevin Bacon problem, we have our movies, right? So we can look at movies and we can give it Bacon, Kevin, right? And this gives us a list or a set of all the movies that Kevin Bacon has been in. So anybody who starred in one of these movies is 1 degree from Kevin Bacon. So we can go through, if we build up, let's do this one. I'm not sure I'm going to get through all of class today, but let's do this. We can have another dictionary, actors dictionary. We're going to do the same thing we did in Occur, except this time, instead of building up how many times people appeared in it, we're going to go through the movie set, and we're going to make each one of the movies in this movie set a key in our actors dictionary, and we're going to put a list of the actors that appeared in that movie. Or maybe, should we do a list? Yeah, we'll do a list. We'll do a list of the actors who appeared in that movie as the value. So we can do the same. It's essentially the same thing we did here, right? Down through here, right? We're going to walk through every actor who's a key in our movies directory. We're going to get the set of movies they were in, and then we're going to say for movie in movie set. Right, that's going to be a list. Movie set's a set, so we'll walk through every element in that set. And now we just ask our question: if not movie in actors, actors submovie equals, we'll do it this way this time, equals key, right? Key is our actor. So we're going to create a list that just has the current actor. Otherwise, the movie already exists in our actor set, so we just have to do an actors.append and the actor name. And we could make this for actor in if we wanted. I think that's all we need to do. And I think I'm going to take this part out just because it's annoying and it actually does. Let's do Hank's first. This one I'm not as confident about. There we go. Dictionary has no actors. I did the same thing the last time. Actor submovie dot append. Okay. And now we can look at actors. What does that have? Down and Dirty, Bonfire of the Vanities. Yeah, it looks like that actually worked. So now we'll run it again with the IMDb data. Okay. And now if we want to look at, for example, actors. I should have looked at one of the. Hopefully this is the right spelling. Nope. The Polar Express. There we go. So, along with Tom, Nona Gay, Leslie Zemeckis, Chris Van Allsburg, and Eddie Deason, Peter Scolari, and Robert Zemeckis were associated with the Polar Express. So, now we have going back to our notes. Now we can go through. We can find out all the movies that Kevin Bacon starred in, and then we can find out from our actors database all the people who starred in all the movies that Kevin Bacon starred in, and these are all 1 degree from Kevin Bacon. And then we go through and we find out all the movies that those people starred in, and we iterate again, and we can kind of solve different types of problems. I think I want to introduce this topic. I will finish this up. What do we have? 2 minutes. I want to introduce this next topic of attribute value pairs, but we'll get into it more at the next class. Attribute value pairs is the concept of, it's kind of like a database concept. So, for example, if you've ever seen a listing for houses, what you'll find out is that not every listing has the same information. So if you're trying to keep a database of information on what's associated with a house, there's going to be a few things. So we can say houses, and maybe we have some identifier for each house, like maybe house 0. This could be a location or an ID or something. But there might be a few things that are always there, like maybe actually houses can be a list. Let's make houses a list. It could be a dictionary as well, but we don't need it to be a dictionary. It just makes it. Right, so now we can go in here, we can do houses.append, and we can append on a dictionary entry. So maybe in our house, we want to have an address, right? And that'll be a string. Right? And maybe in general there's going to be a bedroom, or there's going to be some bedrooms. So we can have another key that's bedrooms. I'm expecting we can find 3 bedrooms on the RPI campus. That's the RPI campus address. And maybe we want a Boolean that's is it available to buy? And that could be true or false, or false. False would work. Right? And we could have, and this could go on. And it doesn't have to be, everyone the same. So our first house could be RPI campus. Right? And our second house, we'll append another one on there. Maybe it's at 108 8th Street, Troy, New York. It has 7 bedrooms, It is available, but it also has a pool. And it'll be an in-ground pool. So now houses is essentially a database of different houses that are available. And there's some information that's common, things like address and bedrooms, and some information that isn't common. Common being shared between them, like a pool. We could have an asking price if it's available. So it's just this whole concept of attribute value pairs. You can have lists or dictionaries or other structures that contain these attribute value pairs, where the attributes are the things you might want to know about the house, and the value is, the value of what that is. The address would be the address, the number of bedrooms would be the number of bedrooms, etc. So we're going to get into that a little bit more in the next class. Until then, I'll hang out for a little bit and answer questions, but enjoy the rest of your week. It looks like it's going to be a beautiful weekend. Get out, get some sunshine, get some relaxation time, and we'll see you back bright and early, 2:30 on Monday. All right, any questions? Let me see.